So our first speaker of today is Mark, and he would be talking about beyond deployment, continuously adding features to drive marginal gains in models. So yeah, the stage is yours.
Can I start? Okay. Is the mic working? Yeah, good, good. Can all of you hear me? Yeah, I guess should be fine. So the fancy name of presentation was already presented. Truth to be told, I asked ChatGPT to come up with something fancy. Sadly, it won't be able to present instead of me, so here I am. Good. So I propose to look into agenda and what I will be presenting today. So we'll start with a short intro about myself. Then we'll have a overall overlook at the model lifecycle. Then we will dive deeper into some of the parts that are relevant for our automated process, and then we'll get back to the automated process itself, and we will see a broader process. And all the time that is left will be for Q&A. Good. So let me start by presenting myself. So I'm Mark. When I was thinking how I ended up in this position I am now, somewhere between data science, engineering, data, etc., I came up with those bullet points. So essentially, my education is applied maths with a focus on AI and modeling. Then the specialization and where I've been working for the entire life after the university is software engineering, and I'm also really passionate about the data. I really like the data flows because it's so. I would like to say it's beautiful to see how you can transform a big data set into something aggregated and get the value outside of it for the business. Yeah, jumping to the model lifecycle. I think that most of you will be familiar with it, although I think that it's different from company to company, or even in Revolut it's different from team to team. So I will present how the model lifecycle looks in the credit department in Revolut. So first of all, it's about data collection. Then we have a feature generation process. And essentially, it's a vital piece of the model development because we want to come up with as much features as possible. And I will be presenting in this presentation how we do that. Then we have feature selection / model training part, which is essentially coming up with the ML model, which will be used. Then, of course, we do deploy it into production and see how it works, and that's already a model monitoring part. But the fun fact about models is that probably if you read the description, you saw that models are never truly done. So as the economic situation changes, as the population changes, we constantly need to monitor for the model performance and find the correct spot and correct way to upgrade it to make it even more powerful and to make it even better. So yeah, we can jump into feature generation. So I would start by showcasing the main types of data sources that we use in credit. So first of all, it's in most of the countries, it's mandated to use credit bureau data. Essentially talking about the raw credit bureau data, it's usually come in XML or JSON formats. And in order to get the most value out of it, we need to build the pipelines which will parse those files and store them in a tabular format. So something that later can be used to come up with features and train the models. Then we have quite a lot of internal data. So probably the biggest data set is in transactions because Revolut is a bank. But we also have the past credit applications data. We have devices or app usage data, which also come in handy. And from those, we can deduce some behavioral features about the user, which sometimes are really predictive of credit risk. And also there's third-party data. So we have multiple vendors who provides us with data, which we also use to either build features or those are pre-built features that we just use for the models. Now getting to how we generate the features. One of the probably one of the most used technique is deep feature synthesis. Essentially, it's really powerful from the perspective of generating a big pool of features because it goes through the relationship in the tabular data and tries to come up with all possible variations and all possible combinations of different interlinked data points to come up with a lot of features. I think it might sound confusing, so I prepared some small example. Usually we use a library which is called feature tools, and it's actually a test data set from this library, and I just came up with some feature examples. So you can see here that we have first level features, which is, for example, average transaction amount, which is super simple. Then we have something even more complex, which is a maximum sum of transaction amounts throughout the sessions. So we select essentially the session which has the biggest sum of transactions in it. And if we go even deeper, feature tools allows you to define interesting values, which essentially can be used as filters, and we can even come up with the features that that do filter by some specific field. So, like in the third example, we are filtering that the session device should be mobile. Good. Continuing, let's go into feature selection process. So we have quite some techniques on how we do that, but I will present the most common one, and it's actually shared across the credit departments in most of the banks, because it's I don't know how, but it became the most used technique for credit risk models. A bit of math. I won't dive deep, I promise. So first of all, we need to come up with weight of evidence. So it's essentially a predictive power of independent variable in relation to a dependent one. The problem with weight of evidence is that it only works with binned continuous variables. So if we have, for example, a sum of transactions, we need to bin it into we need to aggregate those into separate bins. There are, again, multiple techniques on how to do that, and only then we are able to calculate weight of evidence, which is essentially a natural logarithm of the ratio between non-events percentage and events percentage, where events is essentially a binary classification of 1 and non-events is zeros. Good. After we calculated weight of evidence, we can calculate information value. So essentially, it's a technique that selects an important variables in a predictive model. So we are able to rank all the variables from a feature pool. Again, getting back to the deep feature synthesis, sometimes we have feature pools of 60,000 plus features. And this technique allows us to select the most informative ones, which would be best suited to be used in the exact model. So it's calculated as a sum over all bins for the variable. Again, it's a difference of percentage of events minus the percentage of non-events, and it's multiplied by weight of evidence value. Now getting to the most important bit and taking it even one step further, it's a marginal information value. Essentially, it's already a model construction technique which iteratively does select the best feature for the model. So I will talk more about it in the next slide. But just for you to understand from the mathematical perspective, we are trying to see what the power of model would be if we added this particular feature into the model along with all other features. Yeah, now getting to the information value or to the model building process itself. So first of all, as I mentioned, we do calculate information value for all the features. Then we select the most predictive feature. Then we add it to the model, and then we repeat. Essentially, that allows us to come up with the final set of features where n can be controlled. So we can define an end condition. So for example, if we want only 10 features to be inside the model, we can set it and essentially come up with a model with 10 most informative features. Good, and we arrive at the automated process. So probably the core of this presentation. I think I'm rushing a bit now. Yeah, sorry. It will probably be a short one. Good. So yeah, now let's recap everything that that we discussed. So we have a recurrent job that takes all the data sources that we have. So again, as I mentioned, it can be credit bureau data in form of raw files. It can be transactional data stored in our data lake. It can be API data we fetch from API integration with our third-party vendors. So essentially, there are a lot of different data sources, and each data source needs to be processed separately. So we have separate pipelines which take care of processing the data and storing the data in a tabular format, which later can be defined as a features pool. So it's something that you see here. Now, in order to do the continuous monitoring and continuously track which features are adding value, we probably need to store the information of what model already predicted, because then we would be able to compare it to what it would have predicted if this new feature would have been added, and also we need to track our targets. And essentially, all that comes into the final process, which we call MIV calculation. And essentially, the output of this is a list of features along with their respective MIV values, which allows business to decide which features should be added into the model to make it even more powerful. Yeah. I think that's it. Now the time is for your questions. Okay, I can see one question. Do we have a mic? Yes.
Hi, I have two. So one of the questions is, I see that you are using forward selection, but
Yes.
because when you have like correlated variables, do you try sometimes to do things backwards? And
can you make it? Yeah.
do you perform also backward selection? And another thing is like when you're improving the model, do you clean some old features that were important before but have become unimportant at some point in time?
That's one of the next steps that we are willing to take. So essentially rebuild the model from the ground up each time we run the process, because essentially this let me get back to this process. Essentially now we only use it to add additional features, but we could be building the model from the ground up. So each time getting new data, understanding each population, and then coming up with a new model each time we run this process. And the second question? Okay, got it.
So as far as I understood, this works mostly with categorical variables, right? Are there alterations for continuous variables?
So for continuous variables, as I mentioned, we usually do bin them. So essentially we use a binning tree to come up with the bins for the variables, again, depending on the target. And it allows us to separate different bins with different credit risk. So for if we take an example of I don't know, average balance of the user in his Revolut wallet, we would probably observe that users who have an average balance of the wallet from 0 to, I don't know, 200 euros, they are more risky ones. Although those who keep a couple of thousand or even more euros in their wallet, they are less risky ones. So that's more or less the way that we come up with those bins.
Okay.
Are you using linear models for inference?
It depends. It really depends.
I have a question about using weight of evidence, because it directly measures correlation to the target. And if you remove features in the first step by the correlation of the target, you might actually missing features who does not directly gives you performance, but with a combination with another feature, you can have some value.
Okay. Yeah, here again, deep feature synthesis is a good tool to at least partially tackle this problem, because it does unbiased generation of all possible features. And if, for example, let's get to those examples. Where they, yeah, here they are. So let's take a look at the third feature. So essentially, if the transaction amount is not the transaction amount, if the device itself does not correlate with the target, but then we in the third feature we get that maximum transaction amount over all sessions where device is mobile, it already correlates. So this allows us to introduce, yes.
Hi. So I imagine this auto generation process doesn't take into account, let's say, domain knowledge. Do you have also like manual, let's say, data scientists who manually come up with features, or is it only auto-generated features?
So this process allows you to pre-calculate something. So if you want to introduce the business domain knowledge into the process, you can say that, for example, I want not to only look at the amounts, but I want to look at the amounts. It will be nonsense, but amounts multiplied by the by I don't know, a number of products that user bought. So essentially, you can preset, you can inject some business domain knowledge into the process, or you can come up with the manual features as well.
Okay, thanks. And the second question, is this whole pipeline process only, or are these features that you come up with or that are generated only used for batch predictions, or do you also use them for real-time predictions?
So it's both. It's both.
Okay, so you have some like feature store that stores this calculated features, right?
Yeah, so it really depends. So we have couple of business cases. So for example, for live inference, when someone applies for credit, we use live scoring, which takes the features from our feature store and predicts this one outcome. But if we talk about batch predictions, which are used for analytical purposes, for marketing purposes, etc., we have batch processes in Airflow who use our data lake to come up with those features, because calculating features for all users in Revolut, it's quite a big data volume, and we try to utilize our data lake as much as possible.
Any more questions?
Yeah, thanks for the presentation. So my question is, I saw from the feature selection formulas that the target is binary, right?
Yes, it's only for binary.
Is it possible to alter this to do regression?
I think yes, although as I mentioned, I'm not entirely data scientist.
All right. All right.
Yeah, but essentially it's just an example of what can be used. Any other technique would also work, and it's mostly about the process that we need to come up with the feature pool, we need to come up with some feature selection technique, and then we are able either to train the model automatically from grounds up, or we are able to find features which we can add on top of the current model.
Hi. Is this used in the regulated space, as in regulated models can also use this? If at all, yes, how would you deal with model validation and reporting to the financial regulator regarding change in model performance or change of model and everything?
Okay, it's a good question, and actually we have quite a lot of bureaucracy around releasing new versions of the models. But essentially we go through the review each time we build a new model. So essentially any additional features addition would be validated by model risk and second line in Revolut.
Any more questions? We have like a minute.
Okay, if there are no more questions, if you would like to leave feedback on the presentation, please scan the QR code.